Okay, so before we get started on the notes today, for the people who are going to be gone next week for NOLA or for whatever reason, I've really been struggling with this, trying to figure out, because my plan was for us to have a test next Wednesday over Chapter 4. It's a pretty simple chapter, it's a pretty short chapter, and so wham bam, it's time for the test. I'm not really comfortable with that. And so I've decided not to give you a test on this chapter. It, of course, will be on the final exam. But you will have the workbook, which I have up on Dashboard. I just haven't released it, but I will do that after this class. So that will be up there for you. And by this afternoon, the CMC should be up there as well.
Will we have, like, take-home questions like we did for the
No, we're just going to do straight homework assignments for this chapter. Okay. But it will, like I said, it will show up on the final, but I think you should be okay.
So, are we back in the book?
We are back in the book.
I'm so excited to
Miss the book. All right. So chapter 4, the skin and its appendages. Buckle up. Away we go. So this chapter is not just about the skin. It's about the skin and body membranes as well. And so I just want to mention to you, there's basically, your membranes are composed of two different types of tissues. So there are epithelial membranes. Epithelial membranes do contain an epithelial layer. Remember, we talked about epithelial tissue back in chapter 3. So they do have an epithelial layer, but that epithelial layer has an underlying layer of connective tissue. They have an underlying layer of connective tissue. Ella. Yes, epithelial tissue and then an underlying connective tissue layer. So basically, if you take a look at those, it fits the definition of an organ because we have different types of tissues working together, and that's the definition of an organ. So these membranes are actually simple organs. So there are three different types of epithelial membranes. The cutaneous membrane, the cutaneous membrane is your skin. And we're going to obviously get into a lot more detail on your skin since that's the majority of what this chapter is about. But to take a look at the epithelial and the connective tissue layer. So the epithelial layer of the cutaneous membrane of your skin is your epidermis. Which is made of stratified squamous epithelium. Flashbacks? Stratified squamous. So what does stratified mean? Yeah, multiple layers, exactly. And what does squamous mean? What shape are the cells? Like little, yeah, like little tiles, flat little tiles, okay. The connective tissue layer, Angela?
You said stratified, just
stratified squamous epithelium. The connective tissue layer of your skin is the dermis, and it is composed mostly of dense fibrous connective tissue.
What does that look like? Because like, so like this is like the epithelium.
Right, is the epithelial. And there's many layers to that, and so the different layers look a little bit different. But the dense fibrous connective tissue is, we'll actually look at it, what it would look like under the microscope. So you'll see they're tightly packed cells, but they're like moister cells. And like when you get like a rug burn or like that kind of thing, you're exposing your dermis. So that's what,
So it's like right.
yep. Okay, so mucosa or mucous membrane. Most of the mucosa refers to those membranes that line the internal organs that are exposed to the outside. I'm seeing some furrowed brows about what that means. And what that means is things like your digestive system. So technically your digestive system is exposed to the outside because you bring things in and you put things out. It's exposed to the outside.
Oh, so it's not like outside.
It's not outside the body, it's inside the body, but it's exposed to the outside. Same thing with the respiratory system. So the lining of those systems. Now, with mucosa, the epithelial tissue involved varies depending on the location of the mucosa. Yes, varies depending on location. The connective tissue portion is loose connective tissue. A specific type of loose connective tissue called lamina propria. Now, going back to the epithelial layer, because the epithelial layer is the layer that's exposed to the outside. And regardless of what kind of epithelium we have in mucosa, it's a moist epithelial layer. See how many of those words we can get in here today. Yeah. So these tissues secrete. I'm really not doing it on purpose.
Is this still the epithelium?
Yes. So well, just the tissue in general, the mucosa.
Okay.
They secrete, in the instance of, for instance, with the respiratory tract, they secrete a substance that helps with gas exchange. Your lungs have to stay moist for gas exchange to occur. Some parts of the digestive system secrete things that help to lubricate. I don't think that's up there yet. That help to lubricate. So they all secrete some kind of mucus. And the third type of epithelial membrane is the serous membrane, or serosa. The serosa is found surrounding your organs and lining your body cavity. Serosa always come in pairs. And we'll see these periodically throughout the year with different organs. So, for instance, your lungs. There is a layer of serosa that surrounds the lungs, that lays tight on the lungs. But then there is another layer that's tight to the body cavity. And in between those two layers is fluid. We'll see the same thing with your heart. And so what this allows to happen is it allows those organs to slide smoothly against the body wall. So when you're breathing, for instance, you're not feeling your lungs like rasping against your ribs, because you have that nice fluid that allows them to move smoothly against the body wall. Now, I mentioned earlier in the year that there are some parts of our bodies now that they're thinking, oh, that's actually an organ, and we should call it an organ, and it should be part of its own system. And the serosa is one of those that in the past year they've decided. Now, we already said these membranes are simple organs, so hey, why not? They want to make it official, I guess, whoever they are. So the epithelial layer of serosa is simple squamous epithelium. And the connective tissue layer is areolar connective tissue. Going back for just a minute to the two layers of the serosa. The layer that surrounds the body organ is called the visceral layer. The term viscera usually has to do with body organs. You know, when you eviscerate someone, you rip out their body organs.
Oh, I did not know that. What did you say?
Visceral has to do with the body organs, so this is the one that is indirectly in contact with the body organs. And the layer that's lining the body cavity is the parietal layer. So there are membranes that do not have the epithelial layer. There are membranes that are simply connective tissue. And these are the synovial membranes. Synovial membranes are made of soft areolar connective tissue and contain no epithelial cells. They contain soft areolar connective tissue and no epithelial cells. These membranes are found in the joints, especially the highly movable joints. And we'll talk about those. The week of Halloween actually is skeleton week. No. It just kind of happened. It seemed it used to be that we would always end up talking about blood around Halloween.
I guess everything we talk about,
We can apply it to Halloween somehow.
Can we watch a Halloween movie and like point out the bones? Like skeletal strong.
Interesting thought. Interesting thought. So these synovial membranes secrete a fluid that lubricates the joints. Sorry, I had to say that really fast because of all the words in there. They secrete a fluid that lubricates the joints. All right, so let us focus on the skin. So we'll work from the outside in, and we'll start with the epidermis. So as we already stated, the epidermis is made of stratified squamous epithelium. And it is keratinized, which means it has a lot of keratin in it. Keratin, you might remember from chapter 2, is a structural protein. They sometimes refer to it as keratinizing squamous cell, stratified squamous cell, because not all of it is keratinized. When we get deeper into the layers, we'll find that those deeper layers aren't keratinized, but they gradually form keratin as they grow outwards. And so we will take a look at those layers of cells and see what's going on in those layers. We are going to start at the innermost epidermis. Stratum basal, the base layer. At this layer, so the innermost epidermis, the cells are actively dividing and pushing outward. So at this point, they do not have keratin in them. They're just making new cells. We have to keep replenishing our cells since we're losing them all of the time. The next layer out then is the stratum spinosum, the spiny layer. These cells contain thick bundles of pre-keratin. Remember, we said with proteins that proteins are made from multiple polypeptides. So at this layer, we don't have the protein keratin, but we have the polypeptides that will come together to make keratin. Pre-keratin.
So there is that. You said is that the protein waiting for the polypeptide?
That's the those are the polypeptides that will become the protein.
Okay.
So they're pushing further out. At this point, the cells are still alive. But they're getting further away from the blood supply. Remember, epithelial cells don't usually have a good blood supply. As they push outward, they become the stratum granulosum, or the granular layer. Here, the cells are flattened. The organelles are starting to deteriorate. And they are becoming keratinized. This cell is becoming keratinized. And then we get to the stratum corneum, the horny layer. At this point, the cells are dead. And they're basically flat sacs full of keratin. So there are two reasons why the epidermis, is, at least at the surface, when we get to the stratum corneum, is dead. One is it's too far away from a blood supply. And the other is that the keratin has taken over. Mm-hmm. So we talk about, like when you see dust, it's mostly dead cells. And yeah, mostly dead epidermal cells. But I hear concerns sometimes. You mean there's organelles in those cells? No, there's not. The organelles got kicked out before they got that far. Basically, they're just sacs of keratin. But they did used to be living cells. So as far as growth and repair, our epidermis grows and repairs from the inside out. So if you think about like if you have a scab and if you just leave it be and not bug it and give it time to repair itself, okay? And if you have a scab, if you've been bleeding, that means you've gone below the dermis or the epidermis because the epidermis doesn't have any direct blood supply. Okay? But as it grows, as it repairs underneath that scab, it pushes outward until there comes a point where the scab wants to be detached. Okay? It's because the healthy cells are growing underneath it and pushing it outward. And then, what you doing over there?
I was just itching my leg.
Looking for scabs?
Well, yeah, it was a scab that I've been looking at.
Gotcha. Well, and if you do it too soon, if you start picking at it, then if it hasn't repaired enough, then it will start bleeding again.
I have a scar, so it was a scab.
Yeah. Or when you pick off a scab and it is healed enough, but it hasn't healed enough yet, quite enough yet, and it's kind of moist. Okay. That's like plasma is seeping through. So the dermis is the inner layer of the skin. If you wear anything that's leather, it's the dermis of the animal that it came from. So we said that the dermis is its connective tissue. In particular, it's dense fibrous connective tissue. And it has two distinct layers. The upper layer, so the outermost layer, is the papillary layer. The papillary layer is very uneven, and it has little projections called dermal papillae. Dermal papillae. Like papillary, take off the Y, RY, and put an E on the end. And these are what give you fingerprints. Yeah, the projections. That root word papal means nipple. So they're nipple-like projections. They are. And then they make... You do. You do.
So now if someone touches your fingerprints, you're like, hey, don't touch my nipples.
That is a conversation starter.
Indeed.
Every time you handshake
Handshake.
someone,
Stop
every
touching
time
my
you handshake someone, you touch their nipples.
All right. So yes, that's what that means. So those little those indents, some of them contain blood vessels. The little indents, some of them contain blood vessels that supply nutrients, I should say, to your epidermis. Some of them have pain receptors and touch receptors. Epidermis. So you actually have unique fingerprints and on your feet. You have them as well. Yes, you're walking on your nipples. Okay. Elizabeth? It's the outer layer of the dermis.
Oh, okay, the top one.
Yes.
I know.
But the reason why we leave fingerprints and don't leave pretty little footprints, okay, is because there are unique sweat glands that are in our fingerprints as well. There's sweat pores, and that's what leaves the identifying.
You don't have those in your toes?
Nope.
What makes your feet sweat?
Well, you have sweat glands in your feet, but not those. Yeah, not in your toes. Not in those little ridges on your toes. The other layer of the dermis, so this would be the inner layer, the deepest skin layer, is the reticular layer. It has connective tissue, blood vessels, sweat and oil glands. There are deep pressure receptors here.
When you say deep, does that mean like poking yourself and it's not just like...
Right, it's not like a light touch, it's more of a putting pressure on
The
it.
ability to feel pressure.
Okay, one time, like, I cut my finger open and it was like so deep that you could like see kind of like inside it. I'll like make people listen. Okay, well,
Right
I'm
before
just
lunch,
curious,
it's very good.
Would that be like the sweat and oil glands?
It could have been, yeah. Could have been.
Science.
All right.
Science.
The dermis, just in general, contains a lot of collagen and elastin. The dermis in general contains a lot of collagen and elastin. Once again, structural proteins. And so we'll talk about what happens to these when you spend a lot of time in the sun. So collagen helps to strengthen the cells. Elastin gives them flexibility. So like when you smile, your face goes back to normal, and when you quit smiling. All right.